Here we go with systems of equations, linear systems of equations. Two variables. Two variables, got a graph. They're both to the first power. It's a line. Two variables, it's got a graph, first power, line, linear. Not every graph is a line. We've talked about parabolas and circles, and we'll do examples of systems where these maybe are not lines. That'll be called nonlinear systems of equations. All right, that'll be our last assignment, actually, assignment 30. We're on 28 right now, though. These are indeed lines. Again, the question becomes, should we use elimination or should we use substitution? And again, I would hope you would agree that kind of by default, if substitution requires that a variable be by itself, either y equals or x equals, since we don't have that, it seems like elimination would be the way to go here. And another tip off is that the x's are lined up, the y's are lined up, the numbers are lined up. That's conducive to elimination. So we want to eliminate one of the variables. Should it be x or y? Let's flip a coin here. Dang it. I don't have anything. Maybe you're wondering what happened to the dime and the penny that you've already given me. I don't know. I don't know what happened to them. Anyway, does anybody, I'm sorry, I need to flip something here to, oh, you. All right, thank you. I'll come over here, and I sure appreciate you volunteering to give us something here. Oh, now we're talking. All right. Thank you for the Benjamin. Here's somebody that really wants to pass the class. All right, so here we go. How about Ben, heads is x, and then tails would be y. All right, let's flip this here. Now we're talking. Yeah. There, like I said, there's somebody that wants to pass the class. So anyway, we flip it there. It kind of floats around here. And Ben, heads. We're going to get rid of x. All right, we're going to get rid of our x because Ben came up. All right, thank you very much. All right, thank you. I appreciate that. All right, so anyway, we're going to get rid of x. What's the least common multiple for 9 and 18? 18. 9 goes into 18. Sometimes you only need to modify one of the equations. I hope your logic would tell you, you know what, we can just transfer that other one, the bottom one, over as is. We don't need to modify this one. And we'll just multiply that one by 2, and we'll have a negative 18x and a positive 18x. So again, sometimes you only maybe need to modify one of them. Let's distribute 2 on that top equation here. All right. So, 2 times 9, 18x. Oh, look, that's going to get rid of x. Yeah. That's why it's called elimination. Get rid of it. Let's see. 2 times negative 5y. That's going to be negative 10y. And then 2 times 1 is 2. All right. Yay! We got rid of x. That was on purpose, right? That was the design. That's what Ben told us to do. I don't know what happened to Ben, by the way. I don't know. I'm sorry. I don't know what happened there. X goes away. That was on purpose. You know what? Somewhat coincidentally, y also went away. We got rid of x on purpose, but we also got rid of y. There's a 0 over here. And then 2 plus 1 equals 3. There's no variables left. 0 doesn't equal 3. That's patently false. Okay. What has that meant in the past? Well, whenever we've had an equation that behaved that way, didn't we say there was no solution? And indeed, that would still be the same interpretation. So, the answer to this, the solution to this, is that there's actually no solution. And so, these two lines don't have a point of intersection. And you can peek at the notes. Typically, this would be where I would unveil it, but you already have them completely printed out. But how could you have two lines that have no points of intersection? They don't cross. What do we call them? We call them parallel, right? It turns out that if we would have graphed these two lines on some graph paper, we would have seen that they were parallel. They never crossed. Okay, somewhat topical. Aren't they practicing social distancing? And so, there you go. That's the visual explanation of why that occurred. They don't cross. There's no solution. So here again. don't know if you could hear that. There's no solution by Sum 41, our favorite band. All right. Well, thank you. I think that takes care of that one, and we'll have one more scenario to look at.